Hello everybody and welcome to today's webinar. Today's webinar is all about practical survey analysis in Excel. We'll be looking at a lot of things around Excel, a lot of ways to analyse data from your surveys in Excel, and a lot of ways to really understand what those surveys are telling you and what the information is telling you. So the topics for today and what we'll be talking through are quite a few different areas around Excel and customer feedback. So the first thing we'll be doing is we'll be looking at how to design your survey analysis plan. What are the sort of questions that you need to be answering and that you will be answering using Excel, and how will you need to answer those questions? We'll also look at generating some simple statistics using Excel. Excel is actually a really sophisticated tool. It can take a little bit longer to get to an answer than some of the pure statistics packages, but it is a lot more approachable, and you can do pretty much everything you can do in those sophisticated packages in Excel. You just need to know how to get to the point where you're doing that. We're also look at testing your response rate to ensure you have enough responses. The idea of minimum acceptable response rates is something that I hear about a lot, so we'll look at what those minimum acceptable response rates might look like and how you can calculate whether or not you have enough responses. We'll look at graphing your responses so that they inform and not confuse. One thing I know I see a lot of around customer feedback reporting is that a lot of the reporting can be somewhat uninformative, I guess is probably the best answer there. So we're going to try and make the reporting as informative as possible for the reader. We're going to look at testing for significant changes in key variables. That's one of the few questions that you're going to be looking at, so we're going to look at how you test for that and what that means. We're going to be looking at how to uncover the customer satisfaction drivers in your data. So we're going to be looking at that and looking at exactly how you can work out what the drivers of customer satisfaction or Net Promoter Score are in your data. And the last thing we're going to look at is how you can prioritize all this information that you've been provided and actually make some action plans from that. So we'll talk about that as well. So that's the topics for today. The first thing I want to do is just introduce a little bit both Genero and myself. Genero is an organisation we've been around since about 2001, and our organisation is really one that's focused on helping both B2C and B2B organisations and helping them understand what their customers think, how they can use Net Promoter Score and customer feedback in their business, and how they can improve their customer experience. So we're both a consulting organisation and we also offer software to help organisations do that. And that's the organisation. So myself, I'm a founder and owner of Genero. Obviously I've been with the business since it started. Deep experience in customer feedback, Net Promoter Score and customer experience management. So we've literally been doing customer feedback since we started the organisation, and we've been doing Net Promoter Score and helping organisations with Net Promoter Score since it came out about 11 years ago now. Our customers include both B2B and B2C organisations, and we also include small companies and global organisations and multi-industry. So there's a lot of diversity in the sorts of customers that we have, and the principles that we'll talk about here today and the approaches that we'll talk about here today are really applicable to all those different sorts of organisations. Now, I don't like to use the term thought leader, but I've written a lot of blog posts around customer feedback. I think there's around 250 posts on our website. Run lots of workshops, spoken in lots of places about customer feedback, and helped lots of organisations. So that's a little bit about me. So on to the topic for today. So what's really interesting about customer feedback is when you look exactly at what you need to do and the statistics that you need to undertake, rather than there being an enormous number of different questions you need to answer, all of the questions that your survey analysis plan needs to look at really come down to just a few different types of questions. And the questions are these. So the first question is really, are the responses for this question or customer segment significantly different from the responses for this other question or this other customer segment? So the idea that are different segments performing differently, are different questions getting different answers, and are those differences significant? So that's the first question that you have to really look at and really answer. The second really important question you need to answer revolves around the idea that are the responses for this question changing over time? So did we have a different Net Promoter Score or customer satisfaction or perhaps responsiveness value or score in the past than we do today? So that's the second style of question that you're going to want to answer. And the third style of question you're going to want to answer it's really all about whether the responses for one question correlate in some way to the responses for another question. Typically this implies cause or is caused by, and we'll talk about that a little bit later on, but this is really getting an understanding as to whether or not, in Net Promoter Score terms for instance, whether or not this particular attribute question is a driver of Net Promoter Score or customer satisfaction. So what's really good about the fact that we can break our survey analysis plan down into these three ideas is that it really limits the number of statistical analyses that we need to do and statistical tools that we need to understand. And it also means that they're actually quite boxed up. So we can do quite a lot quite quickly and with some kind of template approaches, which is what we'll talk about today. We'll talk a lot about those template approaches. So that's really what we're going to do today. Are the responses for one question or customer segment different from another? Are they changing over time? And maybe are the responses for this one question correlated to another question in some way? So the first thing I want to do just before we get started kind of any further is I want to launch a bit of a poll. And the poll I want to ask you all is, what statistics or approaches do you use when creating your customer feedback reports? So if you can just jump on, tick all that apply for your business. So if you do all of them, tick all of them. If just one of them applies for your business, just tick one of them. So I just want to get an idea of what people are using right at the moment so that we can get a good understanding of what that looks like. Okay, so we've got a few more people. We're getting a few more votes in. If everybody can just jump on and put a vote in now, that would be really good. We'll just wait a few more seconds. Maybe just a couple more seconds for the last couple of people. Okay, I think that looks pretty good. All right, so let's close the poll and show the answers. So I think what's really interesting about this is that almost everybody talks about question averages. So that's good. I guess the things that are really interesting here is the number of histograms that people are using, which is also good. Average confidence intervals is something that you can really use effectively in your reporting to show people what's important. And I think often if we just use averages, then it can be quite misleading for people who are looking at the data that you're providing them. T-tests are also good, and we'll show you how to do t-tests in this sector as well, and correlation. So some people are using correlation as well. So there's a few different techniques that people are using. The thing I really see there is the confidence intervals and question averages. So question averages without confidence intervals can be difficult for people to interpret, and we'll talk about that. All right. Let us move on. Okay. So what steps do we need to take to achieve that survey analysis plan that we talked about? Well, the first thing we need to do is validate the data that we have. We also need to calculate some simple statistics for all of the questions. We need to graph the questions with some error bars, and we'll talk about how to do that. We're going to want to create histograms. So it's good to see some people doing histograms. Histograms are really interesting to do because they can just give you a really quick understanding of what the data looks like and give you a really quick view of what it looks like. If you have past data, you're going to want to plot averages over time with some errors. You're going to need to decide which groups you want to compare and test to see if they've changed. And then you're going to want to do some correlation analysis to see if two variables might be linked. So what we'll do today is actually we'll drop into each of these different subjects and we'll make sure that we have a look at them and show you how to do this in Excel. And all this is quite straightforward in Excel. Okay, moving on. So the first thing I want to do is just say, I guess make a point about what your survey should contain. So typical survey should contain what I call an outcome question. Now this outcome question could be the Net Promoter Score, which is a great outcome question. It could be customer satisfaction, CSAT. It could be customer effort score. There's a few different outcome questions. But that outcome question needs to link in some way to customer loyalty. You're also going to want to have some text response questions, or question or questions, not too many of them, because the more you have, the more difficult the survey is. And you're going to want to have some attribute questions. So you're going to want to ask about some attributes in the business as well. So we can have a really quick look at what a survey might look like. It doesn't have to be super complex. And here's a really quick survey that we can have a look at. So you can see the first question here for the Acme customer survey is, how likely would you be to recommend us to a friend or colleague? This is obviously the Net Promoter Score question. You can see we've got a text question as our second question in here. And then you'll see we've got some attribute questions, and the attribute questions are typically on a 1 to 7 scale. We've got 3 or 4 or 5 of them, and then we have a last commentary question there for any other information the customer might provide. So this is the main style of customer survey that we're looking at. You might have fewer or more attribute questions, but that's the kind of basics of what you're going to need and what we'll be looking at when we look at the reporting in a few seconds. Okay, so that's what the survey needs to look like. Just want to make sure that we all had the same idea of what that was going to look like. So I also want to talk just a few seconds about different types of data, because it kind of is important. So there's a few different types of data that you'd be collecting. One of them is called categorical data, and here's a really good example of a categorical question. So what is your favorite color, blue, green, red, or chartreuse? So this is a question that doesn't have a score against it, but in fact splits customers up, or you can use it for segmentation of your customers. That's the first type of data. We won't be looking a lot at that, but essentially when I talk about different segments and comparing segment scores, that's what you're going to be looking at. What's your, you can split up is the customers who respond blue for this question also for question 1 have a higher or lower score than people who respond green. So splitting the data up. The next data type that you're probably going to be collecting is text data. Now I'll be honest, text data is really difficult to analyze, and we won't be doing very much of that here today because it takes a little bit of review and a little bit of time to do that, and we actually will attack that in a future webinar. But we won't talk much about that. But it's very, very important, because once you've identified the key drivers of your business, it tells you how to improve your business. The qualitative information is critical to understanding what's going to improve your business. The last type of data that you're going to be looking at is what's called ordinal data. And ordinal data is extremely common in customer feedback, and we've just looked at some question that provides an ordinal response. How well did the content that was delivered match what was promised when you registered? 1, very poorly, to 7, very well. So the good thing about these questions is that we know that a 1 is less good than a 2, and a 3 is less good, and a 2 is less good than a 3. So we know the ranking, essentially, of this data. The downside is that it's not a continuous scale. So the difference, the value difference between a 1 and a 2, and a 2 and a 3, or a 6 and a 7 might be different. There might be broader or narrower gaps. So there's a couple of problems, actually, when you talk to a statistician about that. So technically a statistician will say that you shouldn't calculate means for these numbers, and it actually limits dramatically the sort of statistical options that you have for the data, which sounds a bit scary, because every day in companies all over the world, organizations are averaging these sorts of responses, this sort of ordinal data, literally every day. The kind of good news is that although technically you shouldn't be doing these sorts of statistics on ordinal data, there's quite a lot of support to say that practically it's fine. And actually, when it comes to practical use of the statistics and the data, actually it's quite fine to use a lot of these general statistical approaches on this ordinal data we're collecting. So that's a really good sign. The data that we're collecting, whilst technically we shouldn't be doing this, in a practical sense, it's actually very valid and very useful. So if ever anybody comes up to you and says you shouldn't calculate averages on your customer feedback scores, say, well, that's fine. Technically, you're right, I shouldn't, but practically, it's fine to do that. So just kind of something to put in your kit bag of ideas. So we're using ordinal data, and you're going to see us do lots of averages and means for that sort of stuff as we go forward. So I wanted to bring up that sometimes some people technically will say you shouldn't do that. Okay. Moving on. The first thing you want to do is clean up your data and remove invalid or non-numerical data. So it's quite possible to get non-numerical data for very valid and well-constructed survey questions. And here's a really good example here. So please rate the speed of our new service website from very poor to very good with a not applicable. The not applicable obviously is for people that haven't used a service website, so they don't feel that they can actually respond on that particular question. So it's very possible to get NA data or NA values in your survey data. And what I'm going to do now is I'm going to flip backwards and forwards today between Excel and the presentation. So you'll see here, this is the sample data that we'll be working with today. You can see there's an NPS response in the first column. There are a few 7 questions that we've got in the next columns. And you'll see that this data has some NAs. Now I haven't fixed this data on purpose so that you can see that. It's got some NAs and some blanks. So if you have data like this, just remove the NAs and make them into blanks using just the replace function. Find and replace is the easiest way to do that. Replace all those NAs, not with spaces, but with blanks. That's important in Excel because Excel will get a little upset if you don't use if you have text to data where it's expecting numbers. So just make sure you do that. Sometimes you'll see it says, oh, I don't like that, or there's an error. Most often than not, it's because you've got either a space in the data column or you've got something like NA. So just make sure you clean up your data like that. This is typically the best way to have it, typically the way I always make it anyway. And make sure you just fix the NAs or other responses, remove the text, make sure it's not a space. It's just no, there's nothing in that particular cell. All right, so moving on, we've cleaned up the data now. So the next thing you want to do is you want to create a histogram of all your questions. And you do this as a kind of first stage of data interpretation. So for those who don't know, a histogram is a graph of the frequency count of each score. So basically down the bottom you'll see that's what it looks like. Everybody's familiar with that kind of normal distribution chart. And it talks about a count of how many ones, how many twos, etc. It's really good to do this because it will give you a very quick feel for the values, and it's the easiest way to check for a normal distribution. Interestingly enough, when you kind of get into the stats, there are some ways to identify normal distribution from a kind of mathematical perspective or a statistical perspective, but most often than not, the easiest thing to do is to look at it, and if it looks normal, then you're mostly going to be okay. So we've got a couple of kind of not normal looking normal distributions. You've got this kind of right skewed distribution and a bimodal. It's got these 2 peaks. Most of the data, it depends on your business, but you can have kind of slightly skewed distributions like this, especially if you've got very high scores in your business, and actually some of the stuff later we'll see has slightly skewed distributions. So that's what a histogram is. It's good to look at it and just get an understanding of the way the data looks for you. So let's get on and make some histograms. So the first thing you'll need to do to make histograms is actually, well, you can do them lots of ways. You can do them manually, but Excel's got a data analysis pack that you can get. It's a free download for Excel, really easy to use. But you do need to go and get it. So you can either, when you get the presentation, which everybody that's on the call will get, you can go and follow the link, or you can Google Excel Data Analysis Pack and you can download it from Microsoft. Once you've installed it, it's a very standard installation. Once you've installed it, the next thing you do is you need to create a set of bins. So think of bins as the ranges in which you want to count things. So you'll see the bin range we've got here is between -1, essentially minus a half and a half and 1.5, 1.5 and 2.5. So you'll see what we're capturing there is the 0, 1, 2, 3, 4, 5, 6 up to between 6.5 and 7.5, 7. So what you'll see about those bins is that we've put 4.99, and that's to catch, or not to catch, but to kind of put into the right bin anybody that gives a 2.5. So anybody that gives a 0.5 score. If we made that 2.5 to 3.5, it would just move it around in the bins. So these bins are just where the different scores are going to drop, and I think you'll see that when I show you how to do the actual histogram. Okay, then we need to select histogram, and actually what I'm going to do now is I'm going to switch back to Excel, and I'm going to show you how to do it really quickly. So the first thing we want to go across is find, typically it's under data, we want to go to data analysis, and we want to go to histogram, say OK. So there's a few things. We need to put an input range. So this is the data on the input range, and you'll see, actually I've pre-selected it last time, but you'll see I'm missing Q1. This is one of those functions that if you put text into that, if I included the Q1 at the top there, it would fail because it would say, well, it's text and I can't allocate that into a bin. So then we go across and we hit the bins. So now you can see I've selected the bins that we've got -0.5 to plus 0.499, etc., etc. Then you'll see we've selected an output range, so it's going to appear here. And I've also put a chart output. So we hit go, and Excel very nicely for us builds our histogram really quickly, really easily. And you'll see, so this is a histogram of question, I think it was question 1. So you'll see that actually this customer's got quite a lot of high scores. So you'll see, although it says 7.499 here, what that really means is between 6.5 and 7.499. So these are essentially all your 7s, your 6s, your 5s, your 4s, your 3s, your 2s, your 1s. So that's your 1 to 7s that we looked about earlier. And actually what you see with this customer is quite interesting is you kind of have a bit of a bimodal distribution. Like you can see there's a lot of 7s here, which is good, but you can also see there's quite a lot of kind of low scores. So that's kind of interesting in and of itself, and that's why you do these histograms, just to get a bit of an idea about what everything looks like. So the histogram is a really good way, do it for all of your questions, it takes just a few seconds per question, can really give you a good idea very quickly as to what the data is going to look like. All right, histograms. So that's histogram. So create a histogram of all your questions. The next thing we're going to want to do is calculate Net Promoter Score. So for this particular survey, we do have Net Promoter Score. It's not an average. It's actually a particular scoring system which talks about the percentage of detractors, percentage of detractors subtracted from the percentage of promoters multiplied by 100, so it's the score. What's really cool is to calculate Net Promoter Score in Excel is that you can use this COUNTIF function. So the COUNTIF function makes it really nice because you can just count. So you shouldn't really have halves in your Net Promoter Score calculation or in your data for Net Promoter Score. So let's go to the data. So you can see it's like all whole numbers. You really shouldn't have half numbers. If you have got half numbers, you just need to think about it, but I would suggest that you build your survey so that you can't get half numbers is probably the best way to go about it. So now to calculate Net Promoter Score is actually pretty easy because we can go in here and we can use this COUNTIF function. And so what that COUNTIF function there is telling us is it says for the responses in column AA, we've just taken the whole column in Excel. Where it's greater than or equal to 9, we're going to calculate that. So that's your 9s and 10s. They're your promoters. And for the next one down, it's your neutrals. These are your 7s and your 8s. So again, you just count the 7s and you count the 8s. And then the last one is you essentially just count your less than or equal to 6s. So that's kind of really easy to do in Excel. You don't have to do a lot of other work, but this is what I found to be the easiest way to use this count if function. And then we can simply just create a really simple formula which says subtract one from the other, divide by the total number of responses, make sure you get that, multiply by 100, and so that's your Net Promoter Score. And you can see we can chart that really easily. So we just set up a bar chart here that is grabbing the data from these three. Actually, no, I think it's grabbing the data from the percentages. So really simple to do. You can do other cool stuff where you can use exactly the same technique to count individual zeros to tens, really simply to do that as well. So 0 through to 10 and percentages, and then you can chart that. Here I've just done, this was a column chart, so I've done this as a bar chart. This is really interesting to do, and I'd recommend you do this in your survey analysis. You do this approach where you count all of the different scores and you see what that looks like. And this is a really typical Net Promoter Score view, to be honest. Lots of 10s, which is always good. A bit of a peak at 8, so quite a lot of people will peak up at 8. Another little peak here at 5. That's typically you get a lot of people just stick it in the middle and give you a half score. And then a little bit of a peak here at 0, and I've written a whole blog post on the fact that 0 is a particularly important number in Net Promoter Score. So that's also good to look at in a typically in the same way as you look at histograms. It's really interesting to look at it. Just gives you a flavour for the data. So that's how you're going to calculate Net Promoter Score in Excel. A really simple way. The count if function, it works really, really well. It just it ignores any text data in the column, so it works really well. All right, now I want to move on. So we've got histograms and we've got Net Promoter Score. Now I want to move on and show you some of the problems that we often see in customer feedback reports and how to kind of fix them, if you like. So the first problem you'll often see is a chart like this. I've seen this lots and lots of times. We've got the question average for 5.733. For question 2 is 5.733. Just too much precision. These numbers are not that precise. You'll see in a few minutes that these numbers are 5.1 plus or minus about a half a point. So putting 5.133 doesn't make any sense. You don't know how many response volumes, so you don't know whether this has come from 1,000 responses or 10 responses, and that will impact on how much error is in each of these responses. So that's really important to know. If you don't have response volumes, you can't really get an understanding of how much error is here. And the error is the big one. So these are put forward as absolute numbers or extremely accurate numbers, when actually what we have is we have the sample estimate of the population's response to this particular score. So I dislike this kind of misplaced precision and this lack of error. So you need to put error into it. This is the other thing you'll see, the June, July, August, September, the last X number of months of customer survey feedback, and you'll see the scores, and that's great. And so again, you'll see this misplaced precision. This number isn't that precise. But kind of more importantly, it comes up, is this 5.5 to 4.3? Is this September to October change a real change? Is it just statistics? We don't know. We can't tell from this particular view of the data. So what I'm trying to tell you is you want to add that back in, and Excel will I'll show you how to do that. It's really important to do that. Okay, so I don't want to jump into an enormous amount of statistics, but we really need to have just a little bit of a conversation about statistics. So the really important thing to understand here is that the survey responses that we're getting, the 10, 20, 30, 40% of responses that we're getting, are a sample of the overall population. It's not the whole of the population of customers. So because it's just a sample, the statistics we have, things like mean and even standard deviation of the sample, are what's called an estimate of the whole population. So we are trying to estimate the Net Promoter Score for the whole population of customers based on 100 responses. So think about it that way, as an estimate. But there's almost certainly some error range. So we know that our estimate is going to have a plus or minus. It's going to be 5.7, but it's going to be a range on either side. It could be just based on statistical chance. It could be a little too high, it could be a little too low. So we need to have some idea of what that range is going to look like. And then we really need to quantify the error. So we really need to get a good understanding of what that error looks like so that we can make some decisions. Okay. So that's a little bit of statistics that we need just to understand. I don't want to kind of delve into it too deeply. So the next question we often get is, do we have enough responses? So you've got your responses back from the survey now. You've had a little bit of a chance to look at them. You've done a couple of quick calcs. So now the next thing to think about is, okay, well, how much error am I getting in that survey response, or in my responses? So we often get this, what's an acceptable response rate question coming through from people. So this is the calculation or the equation for minimum sample size. And so I just want to go through it a few seconds. And the spreadsheet I'll show you has got it in there, and everybody will get the spreadsheet, so you'll have that. But I just want to go through. So the sample size is proportional to, and this kind of makes sense if you think about it, proportional to how confident you want to be. So if you want to be super confident, 99% sure that you've got the right range, then you're going to need more responses. You're going to need a bigger sample size. If your population varies a lot, so if there's a very wide range of different scores you're getting back, then again, you're going to need more responses. You're going to need more sample size to do that. So if you want to be more confident, or you've got kind of a more variability in your population, you're going to need more samples. On the other side, if you want to have a smaller margin of error, so if you want to be able to say, we want to know plus or minus 0.1 of what this score is, that's also going to make it larger, make the number of responses you need larger. If we can say, oh, plus or minus 2 is fine, then you're going to need fewer responses. So just from a kind of a flavor, think about that. The more confident and the more variable, the larger numbers, the more accurate you want it, also the larger numbers. So I think we've got a response rate. There we go. So what I've done is I've actually pulled that data into a spreadsheet that you can just download and grab. So it talks about all those different areas that we talked about. So we talked about confidence level. We want to be 95% confident in the response that we get. The margin of error, so we want to have the score 5.3 plus or minus 0.5. The standard deviation is something that we've grabbed from the sample already. So from the data you pull back. So using all that information, it says, well, your minimum sample size is 67. That's in order to get that margin of error and that confidence for that sample, you need to have 67 or more responses. So we've got 150 responses. We've had 400 invitations, or there are 400 people in the space, and then your actual response rate is 38%, and your minimum is 17. So obviously you have enough responses to make that. So this is quite a good thing to look at once you have the data. It can be difficult to do this before you have data back because you typically are not sure about what the standard deviation is going to look like. So sometimes you have to look at it, look at when the data's come in and kind of estimate what your margin of error is going to be or what you're going to be able to do. So that's the required sample size piece. So that'll be in the downloadable spreadsheet, and you can just enter the data in blue and it will give you the answers that you need. All right, so do we have enough responses? That's often a question that we get. I want to switch gears, not really switch gears, just go into a bit more detail on this stats, because I want to talk about a couple of ideas that can be a little bit slippery when we're talking about these statistical ideas and these statistical areas. So I want to go through 3 different areas and then show you how they all come together. as we get to the end. So the first thing we want to talk about is a term called standard error. So you'll see standard error thrown around. In fact, in Excel in a few minutes you'll see a place to put standard error. So standard error is a generic statistical term that statisticians say can apply to several or lots and lots of different estimates, means and standard deviations and correlations, all sorts of different things. So all these different ideas, means and standard deviations, correlations and different statistical variables have a standard error that statisticians have agreed on. The important one when we're talking about averages or means is the standard error of the mean is the sample standard deviation divided by the square root of the number of responses. That's how you calculate standard error. We'll see that in a few seconds. But if you see the chart, I think the chart makes it really easy to understand. So standard error is this kind of space in blue under the chart. It tells you, like, this is the standard error. There's another thing which is related to standard error, which is margin of error. And some of these have different terminologies, so I'm giving you a specific definition of these terminologies. The next thing that we'll talk about is margin of error. So the margin of error is the amount within which you are confident, e.g. 90-95%, that the population mean is above or below the sample mean. So the mean is the part in the middle here, okay? And the margin of error is this kind of area under the curve that goes out to the right-hand side. And that is the margin of error is equal to the standard error, which we just looked at, multiplied by a term called T. And T is similar to the Z we saw a few minutes ago. And it's related to the level of confidence you want to have, just like Z is. But it's also related to the number of responses in the sample. And you'll see here I've got 95% and large N. Large N is more than 100. T is about 1.98. Okay, so this gives you the margin of error around which you're 95% sure that that the average looks. So that's margin of error. I think when we go to the next slide, hopefully it'll kind of all come together. So when we talk about confidence intervals, this is where we want the range in which you want the population to lie. And so the confidence interval is the margin, is the mean plus or minus this margin of error. So for example, 4.6 plus or minus 0.23. So you'll see that this graph on the right-hand side is really showing you that the midpoint there is the mean that you've calculated for the sample. The area in blue is the range in which the population, all customers, the mean for all customers exists, most likely 90 or 95%. Okay, so that's how we get to this kind of confidence interval idea. So now we've got that. Let's improve those charts that we had earlier, and let's put some error bars on top of them so that they mean a little bit more, and we can make a little more make it a little bit more useful to people looking at the charts. So immediately you look at this chart, you go, okay, so I know number one, question 2 is about 5.7 plus or minus about a half. Okay, so I have a much better idea now of what that score is. I don't look at it and say, well, it's 5.733. That's unrealistic. So I think I have to go to sample statistics here. So what I've done here is I've just, and I won't go through this whole page yet, I'll go through some of it in a minute, but what I've done is I've just created a chart of the statistics, and this is how you would build it up for your analysis of the data. So you would have the number of responses, and you'll see there isn't necessarily a response for each one of these items. We've got the question averages, we've got the maximum minimum, always good to have in this case, 1 through 7, so quite a wide range of scores. The standard error is in here, and that's the standard error that we had, the standard deviation of the sample divided by the square root of the number of responses, so that's in there. So that's kind of cool. So we're using the count. So count will count numbers. So all those NAs we have in there will be ignored. So we're just going to count the numbers in here, and same with standard deviation. And so then the margin of error we've got and this calculation here up for margin of error, you get the spreadsheet. This is how you calculate that T number. So this is C8 is the standard error multiplied by that T number, and the T number depends on the confidence interval and the number of responses, so that's C4. So that's how we build that out. So everything you see here is exactly what we just looked at in the spreadsheet. In the presentation a few seconds ago. All right. So that's how we get that, and then we just copy it out for all the different things, and then we actually can build a confidence interval. So question 2 is 5.7, but it's actually between 5.4 and 6. So 5.7 plus or minus 0.3 by the looks. Okay, so that's, now we've calculated the data. We go back and we look at the graphing the questions. All right, so let's go now, and what we're going to do is we add error bars. So in Excel, we go in and we add error bars to our chart. So we've charted all this data. So all this data comes from that first row from the spreadsheet that we just looked at, and then there's error bars. So you can see here we can have a fixed value, we can have a percentage, we can have standard deviation, we can have standard error. See, that's the standard error we just talked about a few minutes ago. Or we can have a custom value. And so in this custom value, we're going to use margin of error, plus or minus. So we just tick the box, select it. You'll see that MPS doesn't have a margin of error. I'll talk about that in a few seconds. The negative, so it's plus or minus this 0.293 for question 2. Okay, we tick the OK box. And then it has given us now these charts. So now this chart is way more useful than it was a few seconds ago. Much, much more useful. Okay. So now we've got a chart that we can kind of understand, and we can have a confidence in the size of the error. So just a couple of quick slides on interpreting that margin of error. So you remember this is our 95% confidence interval. So if there's no overlap, you can be sure the difference is statistically significant. So between questions 4 and question 5, it's a real change. If they overlap, then you have to go a little bit further. You actually have to do a test, because you can't be sure because they're overlapping. They might be different, they might not be statistically different. So you have to go along and do a test. I'm going to get to the test in a few seconds. I'm not going to go into margin of error for MPS because it's way more complex, and we've already built a calculator to do that. So it'll be included in the downloads for the webinar, so everybody will get a copy of that. It'll have margin of error. It's also got a chi-square test in there as well, so there's 2 ways of testing. But I'm not going to go into that. There's a whole, when you get this, there's a link to a blog post that'll tell you all the detail, but it's a bit too much to go into for this webinar. All right, so let's go back to this test question that we had a few seconds ago. So we're not sure whether question 1 and question 2 are different. They kind of look like they might be, but we're just not sure because they overlap a bit. So do they have the same average? Now this can be either for 2 questions. It could be the same question for 2 subsegments. So you might do the data for people who like blue and people whose favorite color is blue and people whose favorite color is red. You might have the 2 question 1s and try to compare them. And you might compare scores in June with scores in July. This is all exactly the same question. Okay. We would use something called a t-test. Now the t-test allows us to find the probability that the averages are the same based on the sample, so that the population averages are the same based on the sample. It's called the null hypothesis. Now prerequisites, typically need a normal distribution, so you want to make sure it looks relatively normal. They have to be independent samples, so that just means that they're not paired, so you're not sampling the same person in one sample and the next one. They should be random, so you're not skewing the data. And this is a good one, the data must be continuous. Ours is ordinal, as we talked about at the top of the webinar, but that's fine. We already talked about that and we agreed that that was going to be fine, so we can move on. So let's do a t-test for some of this data. So we go across here. Now the t-test it's really simple if we use this data analysis piece again. So we grab the data analysis piece and we go along and we just go down to find t-test to sample assuming unequal variances because we don't know what the variances are. So let's grab that. We just click on the OK and it says, rightio, what is the input for question 1 or June versus July, or question 1 for people who selected red and people who selected green? So that's question 1, cool. And the other data is for question 2. So that's the other data is question 2, so that's cool as well. All right, so now we want to say, all right, so here's the important thing. So now we're going to say that the hypothesized difference is 0. So remember what we're saying is, are the means the same? Just remember that, that's how we're looking at it. What is the probability that these means are the same? So we're going to say 0. We're going to put an output range here. And then we're just going to hit go. So now it's given us the data. So there's a lot of stuff here. There's a mean, there's a variance observation, there's hypothesized mean difference. Now the number that we really care about is this number here that I've highlighted. So if I translate that, that says that there is a 0.8% chance that those two means are the same. So it's pretty good to say they're not, that we've failed this test, so that the means are not the same. And that's really what you're trying to get to. They are not the same. So now we go back and we've got this data that we talked about. So now if we look at this, we can say that these two means, the 5.1 and the 5.7, although they look like they might be the same, actually we're pretty sure that they're not the same. So there has been a real change or real difference between question 1 and question 2. Now I always have to kind of do this from first principles when I get into this. I have to be honest, I have to look at it and think through it. So what I've done is I've created a little t-test interpretation summary. Excuse me. So the first question, so what we're going to do is, well, there's two outcomes. So if this number here is less than 5%, this B12 number here is less than 5%, sorry, then we're going to say that they're probably different, okay? Because remember, this is the percentage that they are the same. If that number is greater than 5%, we're going to say they're probably the same. You know, there's more than a 5% chance that they're the same. So that's kind of the reverse of the 95% confidence that we often talk about in these sorts of things. So we're pretty comfortable that they're the same number. Now, just a little item on this, the 5% here, it's a line in the sand. A lot of statisticians use 5%. You might use 10% if it's not critical. You might use 1% if it's a super critical part of your business that you need to be very, very certain before you make a decision. You might say it should be 1%. 5% is the typical kind of statistician number that you'll see. So that's a t-test. It will tell you whether the numbers are different. Remember, that was one of the big questions up front. Are the scores different? Have they changed? So we know now between two different areas whether they've changed or not. The last thing I want to kind of delve into is this idea as to, does changing this cause that to change? So it's really driver analysis, and the kind of standard or most common idea about this is this, if I change this attribute, does that attribute change? So if my average handle time goes down, will my net promoter score go up? We need to know that because there's a payoff. If we're going to have a shorter average handle time, we need to have more resources, cost more, we need to make sure there's going to be some loyalty coming at the end. So we need to know whether that's a driver or not. So we'll typically use correlation to do this, and this comes with lots of caveats, lots and lots of caveats actually, but typically let's start with using correlation to do this. And we can do this really quite easily. Correlation tells us whether the two variables move together, whether if average handling time improves, whether net promoter score improves, so they go up at the same time. It's really useful for comparing that output variable. You remember we talked about the output variable right at the top of the hour, so what's the output? So it's really useful for that. there is a kind of a big conversation around correlation not necessarily implying causation, and there have been lots over the years of spurious correlations that are kind of completely unrelated, but they just happen to go together, and there's no causation. That is true, but I always say that correlation doesn't necessarily imply causation, but it's a good place to start looking, a good place to start investigating. A really simple way to do this is actually just to add a linear trend line to a scatter plot. Really simple way to do this, because Excel will do this stuff for you. So we can just add, if I just have to make sure I start this in the right place, I'll insert, so hang about. So what I'll do is I will take the data for question 2 and the data for NPS, and then I will insert a scatter chart. There we go. I will add a trend line. I will call a trend line a linear trend line. I'm actually going to put the R squared on the chart because we'll talk about that in a few seconds. And actually I'm going to move this chart to our charting page. All right, so really simple to do. Took me what, 20 seconds, maybe 60 seconds. You can see now that this line is telling you how well these two numbers move together, just like the other chart is telling you. You see an R squared, I'll talk about that in a few seconds. So you'll see actually this R squared is 0.65 and this one is 0.34. So not quite as well correlated, and you can kind of see that if you look at question 1, it's actually pretty solidly, like it's all in this kind of corridor down the middle. But for question 2, they don't kind of go as closely together. There's stuff where the attributes are 1 and the net promoter scores are 10, and there's stuff where the net promoter scores are 0 and the attributes are 7. They're not as well correlated. Okay, so that's how we kind of do this correlation. Now, okay, so the next thing we're going to do is now, that's the way we do it for a linear chart, but another cool thing to do is actually to add it to our spreadsheet. So let's do correlation, CO, now this is the formula up here for correlation, really simple. Correlation of the sample responses in column B with the sample responses in column A, which is the NPS. So this is our net promoter score correlation, 0.81. And our R squared is 0.65, which is actually just R squared. So it's really kind of simple to build that out. Excel is really quite good at doing a lot of these things. You know, it ignores stuff that's not numeric data and things like that. So it works really well. So now we've got the correlations. Okay. So we've added those to our charts, to our summary stats. So now we just want to interpret this correlation idea. So this R number that you get is an indication of how strong, how linear that relationship is. So essentially a higher R indicates a stronger relationship between the attribute and NPS. So you'll see this one's 0.81, this one's 0.59. 0.81 is a stronger relationship than 0.52. So these two are more correlated. Or question 1 is more likely to be a driver of NPS than question 5 or 6. And I really need to cross the threshold to be statistically significant. And so there's actually a chart, it's in the link here. So this, to be a significant in a statistical sense, this R number needs to go over this kind of threshold number that's in this chart. Don't worry about how the chart comes about, just kind of use it as a reference guide. So for a 90% confidence, which is the 0.1 at the top, with 10 responses, 10 pairs of responses, which is what that is, it's got to be greater than 0.497. So we've got 150 responses, so pretty much all of these are significant. We need to be aware of all these different correlations because they're all significant in a statistical sense. Okay. R squared, which is a number below, is also interesting, and the way to interpret that is that it's the proportion of response variable, so the NPS variation, that is explained by movement of the attribute. So 65% of the movement in NPS is explained by movement in question 1. So that's quite high. That's really quite high. And 27% for some of these ones down the bottom. So question 1's pretty solid. You'd be looking pretty hard at question 1 and saying, what is that and how can we improve on that part of our business? Okay, so that's how you interpret the R squared and the R. Now we get right to the kind of nub of the question. And the nub of the question is, how do I prioritize my focus for improvement? So here we can do some really cool stuff. What we can do is we can graph that correlation number that we've got against the average score. And correlation indicates a linkage to NPS. Again, it's got to be proven, but it indicates a linkage. So that's the number here, importance. And the average score is what we call the performance, how well you're doing. So if you have a look at this chart, you can graph along the horizontal that R score, that R squared score, I think it's R score, against the performance. So what you see here is question 1 is very important and you're not doing too badly at it. Question 6 is probably less important, but you're not doing so well at it either. So if I was in this business, I'd be saying, well, actually question 1 is where I should spend more time. If I can push that up, I'm likely to drive Net Promoter Score up in my business. So I think I've got one more chart for that, yeah. So I can just go back here. So that's really easy to do. You just create an XY chart. You use the data from those sample statistics that we just looked at. So you use these two sets of data here. I think actually I've used this set and this set. Okay. And actually this lower line is just put there to make the chart work in Excel. There's no calculation. So that's how you get this importance performance chart. So that works really well too. So that's the last kind of element. That's identifying what's driving your business. So where would I focus my time? I'd focus my time on question 1, even though the score is more than the question for question 6, because this question 1's more important. So if I put more effort into that, it's probably going to do my business more good. So that's prioritizing my focus for improvement. Okay, so they're the elements that I wanted to talk about today. So one was how to design your survey analysis plan and what we had to do. We've generated some simple statistics, so the averages and the standard errors and the margin of errors and the correlations. We've got those. We've tested the response rate to make sure there's enough responses coming in. We've graphed the responses so you inform the reader. You've got those margin of errors, so we're confident. So we get a real feel for what the range of these scores are. We've tested for significant changes in key variables, so we know question 1 versus question 2 or June versus July for question 1, whatever. We've uncovered the drivers. We've used this correlation to say, well, this seems like it's a good driver of our overall customer satisfaction or Net Promoter Score. We've prioritized our action plan, so we've done that. So that's what we've done today. We've actually pulled all of that. And as you can see, that doesn't take a lot of work in Excel to do quite a lot of outcomes, to get quite a lot of value out of the whole process. Now, on to questions. So I've actually realized I'm probably just around about 5 or 7 minutes longer than I expected to. I will say that on the download page, there is a recording of this webinar. There will be the margin of error spreadsheet for Net Promoter Score, so you can grab that. And there'll also be the spreadsheet I use in this, so in the webinar, so you can just grab it and copy the formulas and those sorts of things. What I tried to do really hard today was narrow down the statistical things you had to do to a limited set that makes sense for customer survey analysis, and essentially give you those tools really quickly and really easily to do. So are there any questions? There are a couple of questions that I might just grab. So the first one, somebody's asking about non-response bias. So what happens when response rates are small? So there's a couple of things. Like if the response rate gets above that minimum that we talked about, that's good. But if the response rate is too small, then there's the likelihood or the chance that some group of people aren't responding. So typically people in the middle of the spectrum aren't responding. They're typically the people you don't see. The very happy and the very unhappy will respond, but the people in the middle don't. So small response rates can cause those sorts of issues, so you do have to be aware of that. So lift your response rate as much as possible. So sometimes above that minimum response rate is a good place to be. Actually, I'm kind of out of time, so I've got a couple of other questions here, but maybe I'll put a text response to those, and I'll get back to those people directly. If you have any questions coming back out of the survey, coming back out of the webinar, sorry, feel free to contact me. Reply to the webinar invite link, whichever you like, whichever makes sense. And that's pretty much it for today. I do want to finish on time, but I think that's just fair on everybody. So I want to thank everybody for their time in coming along. I hope everybody found the webinar useful and they can use the spreadsheet and the tools that we talked about. And I look forward to talking to everybody on the very next webinar. Thanks, everybody.